Rachel, I found a quicker way to solve this problem. You are supposed to find this angle, the angle CDG, which is this small angle in the corner here. The first thing that should occur to you is that is there a relationship between this angle that you are given, this 25 degrees that you are given, and the angle you're supposed to find. And the reason that should occur to you in this problem is that even though you are yet to prove that these two triangles are congruent, they look similar enough that you might suspect that they are in fact congruent. I'm talking about these two blue triangles at the bottom. So given that that's the case, so you are looking, so you will now try to find a relationship that could help you to suggest that this angle is in fact the same as this angle. Well, one thing that comes to mind right away in this case is to try to prove that this triangle GED, the yellow one at the bottom, you want to prove that it's an isosceles triangle. Now, if you can prove that it's an isosceles triangle, and you already know that these angles are both right angles, that is FED and CDE are both right angle triangles. If you can prove that this triangle is also isosceles because these two sides are equal, then you know that this angle right here, GED, is the same as this angle right here, GDE, which means the little bit that will be left on the side, angle GEF, will be the same as angle CDG. So that's the one approach you want to use here. That is, prove that this is an isosceles triangle, and then therefore these two base angles are equal, and therefore what is left of the 90 degrees in each case will be the same. Well, how do you prove that this is an isosceles triangle? Well, we know that this AG is the same as GD. So can you prove that GE is the same as AG? If you can prove that AG is the same as GE, then you are done. Well, that's an easy proof because this is 90 degrees. This point here is 90 degrees on both sides. It has to be 90 degrees on both sides because of supplementary angles. Let me go over that again. We want to prove that AG is the same as EG. So how do we go about proving that again? We know that this angle is the same in both cases, and we know that we have SAS in both cases. This is a common, this line GF is common. This angle is both 90 degrees, and FA is the same as FE. So these two triangles are the same. If these two triangles are the same, therefore triangle line AG, segment AG, is congruent to GE, in which case we have now proved that segment GE is the same as segment GD, and therefore this is an isosceles triangle. Therefore these two angles at the base are the same. Therefore the little pieces that's left on the side out of the 90 degrees on both sides are the same, and therefore you have this angle GDC being 25 degrees, just like the angle FEG. I hope that's clear. That's the quickest way to solve this problem. And if you want, call me and let's talk about it, okay? Bye.